Hey everyone, welcome to day 20 of Math 133. And today we're gonna do our candy project. So after tonight we get to eat some candy. I mean, I'm sure you've been eating plenty with Halloween, but after we're done counting our M&Ms and counting our Skittles, we can eat them. So yeah, so make sure you wash your hands. I already washed mine, so uh, in case you're sharing your M&Ms and Skittles with everybody at home. If not, I mean, if you're just eating them yourself, that's fine too. Um, so in Canvas here, if you click on these two projects, there are links that are going to take you to Google Documents where we're going to fill everything out. So this first one, info and pictures, you click on this link and that'll bring you to this. Um, it's info and pictures, but really it's just pictures. So, um, and then the other one in Canvas is the Candy Project data and graphs. So if you click on that one as well, there's a link, and that's going to take you to this one where we'll fill in this table and we'll do two graphs. Okay. All right. So, um, the first link that I showed you, info and pictures, you're going to need a bag of M&Ms. And you're also going to need a bag of Skittles. All right. So I've already told you guys about getting those. So what we're going to do today is organize the candies by color on a flat surface by color. Why does it say by color twice? Um, take a picture of each of your bags, and then submit the photos of the candy here. Use candies to submit data. Okay, yeah. So, um, okay. So there we go. So let's get started. So, the bag that I have, I've got peanut butter M&Ms because they're the best. So, but I got 9 ounces. So, depending on what size they are, it really depends on how much you need. So if you got the regular M&Ms, then you can probably get away with like 3 ounces. Um, although uh like definitely I like the peanut butter ones or the peanut. Um, but like there's lots of options now. Is anyone like just the plain ones as their favorite? Like, I mean, I like chocolate, but like that's not my favorite. So, and then we'll just sort them out. So we got these over here. This one's like almost a perfect sphere. Like, hmm, interesting. It was rolling on me. So, what's you guys' favorite M&Ms? Anybody? Cindy,
I
what's your
like
I like
favorite?
the
peanuts.
espresso ones, but they only come in 4 colors and they're all a shade of brown.
Oh no, that won't work. Espresso, peanut, regular, really? Oh my goodness. In the microwave. Okay, okay. What was yours, Cindy?
I like peanut.
Yeah, peanut's good. I like
I
peanut.
don't know. Almond sounds really good too, though.
Almond is good. Almond is good. Just the normal one, huh? Interesting. So yeah, so if you get just the regular ones, you probably get away with like 3 ounces. Or if you just bought like uh for Halloween, if you just went trick or treating, you probably got a ton of them. And so if you open like 5 bags, I think like each bag is like an ounce. Um so the question is like, is that okay? Because like, this is supposed to be our random sample. So if I have one big random sample, is that better or worse than if I have lots of small random samples and I mix them together? And the answer is that in theory, it doesn't matter. If you do a random sample and you mix it together with another random sample, then it's still all random. Um, the issue comes in if one of them is biased, or if both are biased. So, because that can throw things off. But I'm assuming you didn't go in and pick out like, oh, I'm going to eat all the red ones first before I count. So I'm assuming you didn't introduce bias into it. So, all right. So there's all my stuff all sorted. So I've got 6 colors here. Still can't see them all though. Move my blue ones over here. Yeah, I put mine on a cookie sheet just so they didn't roll off my desk. I did wash the cookie sheet. I know it looks like but that's all just like burnt on stuff. So, um, all right. So now that I've got everything sorted out here, um, we are gonna take a picture of our M&Ms. Oh, before we can do that, we need to do file, make a copy. So file, make a copy of this. And this one is, all right. And I'm going to save this somewhere. So you can save it in a folder that you might have already set up, or you can just save it in My Drive. This one's important though, that you're going to want to make sure you save this in a location that you'll be able to get to, because we're going to use this data for the Chapter 9 project on Thursday. And we're also going to use the same data for the Chapter 10 project and Chapter 11 project, okay? You don't need to save your candies for that, but you do need to save the data, which is the numbers we're going to fill in a second here, okay? All right, so I've got that. And now I'm going to put my picture in here. So I have a handy dandy camera that lets me, let you guys see my desk. So I'm just going to use that. But you guys are welcome to take a picture on your phone and just attach that however you want to do it and paste that there. All right, that looks great. And I'm not going to do the skills picture yet because I want to count before I do that. So let's go to our data and graphs, and we'll do a file, make a copy on this. And again, let's save this in My Drive, make a copy. All right, so for this one, this data is going to be used for all of our upcoming projects. So we need to count how many of each color of M&M that we have. So hopefully no one's got colorblind issues to the point that they can't separate them. If so, see if you can get someone else to help you. But what color did I want first? Orange one first. Okay. So I like to count by fives. So I'm going to separate these by fives here. And I got some leftovers. So I have 5, 10, 15, 20, 25, 26, 27, 28, 29. 29 orange. Oop, that's the wrong one. All right. Blue. So 5. I got another one that's like a sphere ball looking one. All right, so I got one left over, so 5, 10, 15, 20, 25, 26. All right, green. 5, 10, 15, 20, 21. So you'll notice that these numbers are not the same, right? And that's partly because we have a random sample, right? So ultimately, when you do a random sample, you are going to have a little bit of fluctuation, up or down. Uh, but if you do it enough, if your sample is big enough, then that fluctuation is going to kind of even out. Um, or maybe our population is biased. So our sample is the M&Ms that we've collected. So if you think there's a bias, then that means that maybe there's not as much green created by the M&M company. So I think we can make a safe assumption that the company that makes M&Ms makes the same number of each color. So our population proportion should be 1 out of 6 for each color. All right, so for yellow, I've got 5, 10, 15, 20, 25, 28. Oops, 28. Red. 5, 10, 15, 16, only 17. So, maybe there is some bias. Maybe red dye is more expensive. So maybe we can make the assumption that they produce less red. I don't know. And lastly, brown. Brown doesn't really strike me as an appetizing color. Like, I don't know, like you would think that they'd use a more fun color like purple or pink. Actually, I don't know, to me, like this is a purple Skittle. I think that purple Skittle looks the same color as the brown M&M. I don't know why they don't just do purple. Anyway, 5, 10, 15, 20, 23. Although my wife says that I'm colorblind. Every time she tests me, I'm not, but she's like, you do not know colors. So I don't know shades of color. That's the issue. Okay, so now we need a total on this. So 29 plus 6 plus 21 plus 28 plus 17 plus 23. 144. All right, that looks good. So that's probably more than we needed. But remember, the bigger your sample size, the more accurate your results are going to be. So you definitely need, if you want to meet the central limit theorem, we remember that for central limit theorem for means, you needed 30, a sample size of at least 30. But we're not going to be doing this for means. We're going to be doing this for proportions. We're going to be measuring the proportion of each color. So for proportions, you'll remember n times p times q, that has to be bigger than 10. So what that means is to meet the central limit theorem, you need at least 60 or so, right? Because 60 times 1/6 is 10. Well, you'd probably need more like 70. So because then 70, 72 times 5, 6, that would be 10 on the nose. So but anyway, so if you're lower than me, that's fine. Or if you're more, that's fine too. So what totals did you guys get for your M&Ms?
I got 178.
178. All right, sounds good. Ivana, 140. I had 144. You had 145. So close. Now, I'll be honest with you. If you watch the video from this morning, uh, my counts don't match up with the counts tonight. And it's not because I ate one, but I had 145. Uh, I accidentally knocked over the bowl and stepped on a couple, and so uh, yeah, it's candy down. So anyway, it's fine. Yeah, it was an accident. Okay, so that all sounds good. Um, Next we're gonna do Skittles. So, for Skittles, I also got a 9 ounce bag. And I probably didn't need a 9 ounce bag since Skittles are a little smaller than my big, huge peanut butter M&Ms, but get these all sorted out. So for chapter 9 and 10, we're going to be looking at single populations, but for chapter 11, we'll be looking at two populations at the same time. And that's why we needed you to get Skittles that were the same color as M&Ms, just for the chapter 11 stuff. So um, there's yellow, green, orange, and red. Like I said, I almost feel like you could count these purples as browns in, or the brown M&Ms as purples, but there's no blue. No blue M&Ms in the regular bag. But we're basically going to look and see if there's uh, a difference in proportion. And we know that there is, right? Because there's only 5 colors of Skittles, so um, we can make the assumption that each each Skittle color, there should be 1/6. Sorry, 1/5. 1/5. The proportion for 1/5 of your Skittles should be orange, 1/5 should be red. Although, so my favorite Skittle flavor is red, and I always feel like there's never enough of the red ones. Um, so for a while there, they were doing uh green apple Skittles, and I liked those. I don't like the yellow ones. I don't like I mean, they're fine. It's still candy, but I don't love the yellow lemon Skittles. And lime is like it almost tastes the same. It's marginally better. So yeah, I liked the green apple. What are you guys' favorite Skittle flavors?
I'm gonna go with red too.
Red. Okay. Elaine let me down this morning. She was like, I like the lemon ones. I was like, what? You gotta be kidding me.
Yeah, no.
I mean, it's fine. It's just, yeah, I like the red ones. Purple's good. Orange is good. Mhm. All right. Get quick CO mold there. There we go. Get my picture here. Mhm. All right. All right. So my Skittles picture here. Paste that. There we go. Okay. So this one's done. It's just the two pictures that I need. So we can come over here to the info and pictures. We can submit that one. Oh, only if I'm in the student view. All right, so click web URL. Oh, whoops, I got to share. Yep. So go back over here to the share button in the upper right, change our access to anyone with the link, and then we'll copy this link and we'll paste it here and submit our assignment. All right, we got fire confetti. So that's for the info and pictures. Try to make sure, try to put it in the right spot. I mean, if you switch them and you put that one in the data and graphs, it's fine. I just gotta, it's more work for me. That's okay. Okay, so that one's done. Now for the data and graphs, we gotta get our counts for each of our colors here. So let's count our orange Skittles. Oh. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Green. So if you don't like counting like by fives, that's fine. Another way you can do it, fast counting, is to make rows and columns. So, and then you multiply how many rows you have times how many columns you have. Because counting one at a time, one, two, three, that's just terrible. One, two, all right, so 5, 10, 15, 20. Oh, nope, this one doesn't have 5. 5, 10, 15, 20, 25, 30, 35, 40, 45, 43. Yellow. Come on, I can show you what I mean. So this is a little harder since they kind of roll away from you. That's enough. Oh, wait, purples. Not counting you yet. One left over. So another way you can fast count. So how many columns do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. How many rows? 1, 2, 3, 4, 5, 6. 9 times 6 is 54, and this makes 55. So I like to do fives. That's my preference. I suppose you could count by twos, 2, 4, 6, 8, 10, but I think that's still slow. 5, 10, 15, 20, 25, 30, 33. Oh, wait, I was supposed to count. That was purples. I was supposed to count red next. All right. Sorry about that. Got myself mixed up. I have 10, 15, 20, 25, 30, 35, 40, 45, 46. right, well, I guess I can't complain that I don't get enough reds because purple was fewest for me. All right, let me total these up. So your numbers are obviously going to be different from mine, which is a good thing. We want everybody to get a chance to uh, try out this math with their own numbers, okay? 6 and 33. Whoops. There we go. 227. All right. Now that we've got those counts, dig in. You can eat your candy now. Just make sure we save that in a location that you'll be able to get to for Chapter 9 project on Thursday. All right. Question 3, create a bar chart of your M&M data in StatCrunch. And then question 4, create a pie chart of your Skittle data. Okay. So for your bar chart, you want each color, you need the value displayed above each color. So in StatCrunch, we'll do graph, bar plot with summary. Be sure to select display value above bar. Okay. So let's open up StatCrunch. Statcrunch.com. All right. In the upper right corner, you'll want to sign in. I was going to eat one, but I still need to talk. So who's already eating their candy? All right. Nice. Love it. Good on you, Jacob. Eat your candy. All right. So uh you can type these numbers in. For me, I'm just going to copy and paste them. So I'm going to start with copy and pasting the color. So if I do Control C, copy that, it's giving me an extra line. That's fine. Color. And then my numbers. All right. Uh, you could have also just typed them in, but I like to just copy and paste. That's me. But you could
How are
just
you
do.
doing that? It's not allowing me to paste in StatCrunch.
Oh, okay. Are you signed in? That's the first question. And
Yeah.
then if you are, so you'll need to highlight the numbers you want. If you highlight the entire chart like this, it's not going to work. But if you right click and then copy, or you hit Control C, then when you come over here to StatCrunch, you'll click on one of the cells and you can hold the control button and hit V, Control V. You'll notice that if you copy and paste the numbers and the colors at the same time, it gives you a crazy mess. So you got to do them one at a time, unfortunately. But if that's not working for you, that's totally fine. You can just type the numbers in. It doesn't take that long. And really, the copying pasting isn't going to save you that much time when we've only got 6 numbers to type in. The copying pasting is kind of a muscle memory for me because I'm usually dealing with data sets that have thousands of rows or, sometimes hundreds of thousands of rows. And so copying pasting is way faster. There's no way I could type those in. So, okay. So once you've got your uh, data here, we're going to go to graph, bar plot with summary. And our categories are the colors, the counts are the numbers. The numbers, or frequency is actually the correct title, right? These are frequencies. And we'll hit value above bar. So put your categories are color, counts our number and click value above the bar, and we'll hit compute. And there we go. Okay. And this is an important step. When you have collected your data, which, that's what we were doing here. We were doing data collection. Data collection is the first part of data analysis. Although it's not always the data analyst that collects the data. It might be, someone else in the business or whatever, and you have to get access to the data. But once you have the raw data, the first thing you want to do is visualize it. Okay. Because, I mean, you can look at the numbers and you can see, oh, red is the lowest, orange is the highest, but it's hard to tell just looking at those numbers how they compare to each other. Versus if I look at this bar chart, I can easily see that red is a little more than half of orange. Okay. So humans are very good at seeing visual patterns. It's something that takes a lot of effort to train a computer to be able to do. We're just now getting into, people using AI and stuff, and versus, a human intelligence which can look at this and see patterns jumping out right away. Okay. Even patterns that aren't necessarily there. Okay, we're good at seeing. Okay, so I'm just gonna paste this chart into my project right here. Yeah, so there's actually a couple of data sets called Anscombe's Quartet, which is a very interesting data set that it's 4 data sets that all look very similar when you look at them in table format, but when you graph them, they're clearly very different from each other. So next we're going to do a pie chart with our Skittles. So let's come back over to StatCrunch and copy and paste our Skittle data in here. So we don't want the total, by the way. If you graph with the total, you're going to have one bar that's like crazy large. So you don't want that. You want just the colors and the numbers, not the totals. Okay. And if I just call this color, I'm going to have a bit of an issue because I have a color column here and a color column here. So I'll call this colors for Skittles and numbers. Or you could write Skittle count or whatever. It's fine. Because when you do graph pie chart with summary, you can see that it's listing all of the columns that I have. So if you did call it color, it's just the second one. It's fine. And number, you don't need to click anything else. It will give us the numbers already. And you'll hit compute. And we get our pie chart. Oh, except it's gross. I mean, I've already complained about pie charts. I'm not going to complain more, but like, now I'm going to complain that my orange bar is wedge is red and my purple wedge is green. Um, there's probably a way to rearrange them so that the colors are correct, but we're just gonna not worry about it and just paste this in here. So, um, for number 4, we're gonna paste uh, our graph here. So, um, and like I've said before about bar charts versus pie charts, I mean, you can see that purple on my screen, the purple is the smallest, the purple green. Yellow is the biggest. What's that? Sorry, I didn't hear what you said, Kara.
Didn't realize I was unmuted.
Oh, no worries, no worries. So, if you don't need to do a bar chart of this, but I always find it's a lot easier to see what's going on with a bar chart because I can see with the pie chart here that purple is bigger than yellow. Purple is smaller. Purple is my smallest. Yellow is my largest. But I can't really tell like if the purple one is exactly half of the yellow or it's a little more than half or a little less than half. If I had graphed it as a bar chart, it makes it a lot easier that I can see like, okay, my purple one is definitely more than half of my yellow. So there's actually a psychological effect called the Stroop effect, where if I asked you what color is this wedge, it takes your brain an extra second to say, oh, it's blue, because the word is green, but I'm asking you what the color of the wedge is. So it's called the Stroop effect, named after a guy named Stroop. So there's actually a game, two games that I know of based on the Stroop effect. So okay, so we're gonna just share this up here. Change restricted access to anyone with the link. Copy the link. And data and graphs, make sure I'm in the data and graphs. And I get my confetti. All right, I got balloon confetti. All right. And that's it. So, when you're doing data analysis, the first thing after you have done your data collection is you want to visualize your data. And those visualizations are not necessarily for anyone other than just yourself, but it is a very important step. We'll do deeper analysis where we actually do some math and some statistics. We'll use the normal curve and do some confidence intervals for chapter 9. We'll do that stuff on Thursday in our chapter 9 project. But yeah, it's always important to visualize your data. So, but if you don't have any questions, I hope everybody has a good night. Enjoy your candy. If you do have questions, feel free to stick around. Otherwise, I will talk to you later.